Good morning. My name is John Fardulas from a Sydney-based company called Mobility Robotics, and today I'm going to present a case study in how to use drones for good in humanitarian mine action. Highlights of a project implemented in the central North African country of Chad will be shown, which was led by a humanitarian organization called Humanitarian Inclusion, together with my company, under the auspices of the High Commission for Demining in Chad, the HCND, and funded by the Belgian Department of Foreign Affairs. The problem is deadly hazards from landmines, explosive remnants of war, and unexploded ordnance are left behind after war's end, posing a problem for decades for local populations. Such hazards can cause human suffering, with more than 8,000 casualties last year, threatening 60 million civilians in more than 60 countries and territories. Often, the most vulnerable people are at risk, particularly children, as landmines and unexploded ordnance don't physically look threatening. So in many countries, education is required to teach children not to touch such objects and to stay away from suspected hazardous areas. There's also a greater humanitarian impact, as cutting off access to areas inhibits transport, access to food production, access to water, access to education, energy, and local economies. We found many places where livestock was killed from stepping on landmines, and in some cases, herders entered the minefield to try and rescue injured animals, resulting in human death. Landmines and unexploded ordnance can also be reused and harvested by non-state actors as primary ingredients for improvised explosive devices. Today's presentation is about how small drones can help. We use two main sensing types: visual imagery, capturing surface evidence, primarily from low-cost consumer camera drones, to identify the location of animal accidents, vehicle accidents, explosive craters, and abandoned roads that provided patterns, surface patterns, that gave us insight into where mine roads may exist. And also from a more advanced perspective, using thermal or IR imaging to locate anomalies on the surface from temperature differences created by the buried objects. Now I'm going to provide examples, sharing lessons from the field regarding three main techniques used, which were inspection, cartography, and advanced sensing. The first example is a site assessment from 400 meters away using a small consumer camera drone. The question is, what made this tank stop? Did it enter a minefield, or was it stopped by some other means? So what we're looking for initially is signs of landmine explosions. Can we see any craters or any damage under the tank that might have been inflicted by anti-tank mines? Circling the tank, we can't see any signs of landmine explosions, but there are some abandoned live rockets on the left and on the top of the tank in the rear left quarter. Zooming in, we can see that the make and model of the rocket and see that they are unfired. So they're still live hazards for the local community. Coming closer, we can see how many rockets there are visible from above, helping to quantify the task and giving us an idea about what sort of resources are needed to clean up the area. Here's another example of capturing visual evidence regarding two different types of mines, and it shows how visual evidence speaks every language. In this case, the mine on the left is a bounding fragmentation mine that shoots up and has a blast radius of around 10 meters. So operating procedures in dealing with this mine are different from others. Another example is inspecting this vehicle accident, which is 350 meters into the hazard area. It took a human deminer 1 week with a metal detector to slowly open a path to near the vehicle compared to 15 minutes flying with the small drone. And now an example of cartography, still using visual evidence, but capturing imagery covering a much larger area, the entire site. What you can see is the vehicle accident from the previous slide, which lines up with an animal accident about 150 meters away, and also an explosive crater. These all seem to be along the line of where a legacy road, an abandoned road, used to be. So these patterns give us surface circumstantial evidence that increase the probability of finding where the mine road was. This site costs several $1 million to clear. So if we can gain even 10% in productivity, that could be a saving of hundreds of thousands of dollars. Here's another example of how we use cartography in conjunction with other assets. Small drones won't work alone. They'll work in conjunction with ground assets such as humans, mechanical and animal assets. In this case, we've got an expensive armor-plated ground robot that tills the surface to dig up landmines, but it can only work at up to a maximum incline. So being able to create a map showing the incline and the slope of each part of the site can help better planning and gain increased productivity from the most expensive asset of the operation. Another example is mapping the area to determine environmental influences. In this case, landmines were moving when flooding occurred. So if we can map from the small drones where the water channels exist, this can give us an idea about the path along which the mines are moving and where they're being deposited. And now for advanced sensing. We achieved a world first in proving the value of small drones with thermal cameras over actual minefields in the Sahara Desert. The image you see on the left is the Sahara Desert minefield, where we don't see any surface evidence of buried landmines. The image on the right shows anomalies created from the temperature difference from the buried landmines, where 7 landmines are present from anomalies that we can see on screen. Here's an example of the impact that thermal imaging can have. If you look closely, the thin red line in the middle of the screen is a GPS trail of where anomalies from buried landmines were found by the thermal camera. There's a need in mine action to work systematically for safety, which often means that ground assets are deployed in much greater areas than where the actual contamination exists. In this case, being able to better pinpoint can start operations directly over where the landmines exist and have ground assets work from the inside outward. There was more to the project than just the drones. We had to help set standards, as drone regulations don't exist in Chad, and also delivered 2 diploma levels of training to local pilots. Operating drones over deadly minefields is no walk in the park, so competency was key. I'm really proud of this image. Pictured is Hassan sitting his level 2 exam. Hassan is a guy that doesn't have his own laptop and had to learn Google Earth from scratch to be able to draw the polygons to send to the drones for automatic mapping missions. Now Hassan is fully competent in operating small drones over deadly minefields from a guy who had never seen a drone before. There were also higher risk experimental and advanced operations beyond visual line of sight flight during the day and night over active minefields, plus closer proximity operations to where the risk of detonation was high enough to require the wearing of body armor and protective headwear. We've been really fortunate to have the value of the work acknowledged and recognised by expert groups. For example, the Australian Association for Unmanned Systems awarded myself and my company the 2020 Humanitarian Industry Champion Award, and also the project was awarded a €1 million Horizon Prize from the European Commission. And finishing up with what's next. New funding streams need to be found. Deployment in more countries needs to take place. There's scope for research collaborations and also potential for collaborating regarding defence innovation, because the dual use of what we're doing in humanitarian theatres could also be used for forward reconnaissance regarding improvised explosive devices during active conflicts. That concludes my presentation. Thank you for your attention, and sorry for trying to squeeze so much into such a short period of time.